This week we'll be looking at how to solve a right triangle. Now a triangle has three sides and three angles. So when you're solving triangles, you have to know at least two things. Well, two things really. You need to know either two sides or two angles or a side and an angle to do some type of solving. So you need to know two things, either a side or an angle, two sides, or two angles, and you could do some solving. Now there are actually just about three things, you could call it four if you want, but three things really that you need to know. We sometimes call them tools. So you need to have three tools in your toolbox to be able to solve right triangles. The first one is called the sum angle theorem. Now this is a relationship between all the angles of a triangle. So if you call the angles A, B, C, see the angles are at the edges here, A, B, C, and the sides are normally written in lowercase letters. So opposite angle C would be lowercase c, opposite angle A would be lowercase a, which is side A, opposite angle B would be the side B. But the sum angle theorem is a relationship between only angles. So it says that angle A plus B plus C equals 190. So if you know any two, you could find the third by formula manipulation. So you could put the C over and the B over, they become negative. So A is 180 minus B minus C. And you always have to remember your formula manipulation. It's going to be an invaluable tool. That's another tool for you. You're solving linear equations and manipulating formulas. Those are really important tools. All right, so that's one tool. Since we're talking about right triangles mean that one of the angles, in this case C, it's 90. So if you recognize that 180 is really 90 plus 90. So if C is already 90, it means that A and B together must add up to 90 degrees. So that's important to know also, that in a right triangle, if you exclude the 90 degrees, then the other two angles must add to 90 degrees. All right, so that's a relationship between the angles. Now for the sides. In a right triangle, the side opposite the 90 degrees is called the hypotenuse. And we're going to call the other sides side 1 and side 2. Sometimes we call them the short sides because the hypotenuse is the longest side. So for the Pythagorean theorem, there's a relationship between all three sides, the two shorter sides and the hypotenuse. It says that if you take one of the short sides, you square it, you take the other short side, you square it, the value, you add them together, you'll get what the hypotenuse squared is. You've all seen what they call the 3, 4, 5 triangle, where the hypotenuse is 5. So if you take 3 squared and you add that to 4 squared, you get 3 squared, it's 9, 4 squared, it's 16, you add it, you get 25, and 25 is actually 5 squared. So what we get is that 3 squared plus 4 squared, that's 5 squared. Okay, now again, if you know any two, you could find the third. If you want to find the hypotenuse, well, the hypotenuse is already the subject. So you just add those two sides, well, you square them, add them, and you get the hypotenuse squared. Now, if you know, say, the hypotenuse and the short side, and you want to find the other short side, well, you have to move this over on the other side. So that's formula manipulation for you. So now we have looked at the sum angle theorem, relationship between all three sides, relationship between all three angles, for the sum angle theorem. The Pythagorean is a relationship between the three sides. Now, for the trig ratios, there's a relationship between two sides and an angle. So let us look at this one here. The sine of an angle is equal to the opposite over the hypotenuse, and we'll talk about what is opposite and hypotenuse once we start the lesson. The cosine is adjacent over hypotenuse, and tan is opposite over adjacent. And you probably have seen this before. SOHCAHTOA, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. And again, there are three things here, right? One, in each of these ratios, there are three things. If you know any two, you could find the third by formula manipulation. Now notice for 3 I have A and B. For A, you're going to be given an angle. Say you're given this and you're given that, the opposite, and you have to find the side. Okay, same thing here. You're given an angle and the side, you could find the other side. If you're given an angle and the side, you could find the other side. However, there are times when you're given two sides, say you're given the opposite and hypotenuse, and you want to find an angle. Now you have to use something called the inverse trigonometric ratios. On your calculator, you will see either just above sine, cosine, and tangent, you'll see sine -1, cosine -1, tan -1. Some calculators you will see arc sine, arc cos, and arc tan. What this means is the angle whose value is. Okay, so that's all we're going to say about this. We're going to now jump into the class material. Okay, so we're into the lesson now. The first thing we're going to be looking at is the sum angle theorem. But let's sort of go through. So what this says here is that your right angle triangle theory. So trigonometry, you've seen that term before. Trigonometry involves the study of right triangles. Now, what is a right triangle? A triangle that has one of the angles being 90 degrees. So something looking like that. But you normally represent the right angle with that sort of thing there, like a box. So if you have a right angle, this is 90 degrees. The side opposite, the right angle, opposite meaning, well, these two sides here contain the 90 degrees. So not these two sides that contain the angle. The other one is called the hypotenuse. So opposite always means the side that is not involved in containing the angles. So now the side opposite the side opposite this angle, say this angle here, the side opposite this angle, well, this angle is made up of these two sides. So the side opposite this angle would be that length over there. And likewise for this angle, the side opposite would be that one over there. Now let's label the triangles. Normally for a right triangle, you label the right angle uppercase C or something. Very common. Not always, but it's common. We label the other side arbitrarily arbitrarily A and B. So angle C is 90 degrees. Angle A and B are less than 90. Now, as we said at the introduction, the sum angle theorem means that A plus B plus C is 90. But because C is 90, you have A plus B that must be 90 degrees also. All right, so let's go through this. A right triangle has 190 degrees. The side opposite to the right angle is the longest. It's called the hypotenuse. If the 90 degree angle is labeled C, the hypotenuse is labeled with a lowercase c. We talked about that. If the other two sides are labeled in B, then side A is always opposite to angle A, and side B is always opposite to angle B. The sum of all angles in a triangle is 180. We talked about this, so this is really what we call the sum angle theorem. But for the right angle triangle, which is like that, right? Then excluding the 90 degrees, if you call that A and B, we know that A plus B has to be 90 degrees. So that's all there is to be said about the sum angle theorem, and we'll do examples very shortly. Now, the Pythagorean theorem, as we said, is a relationship between all three sides. So whereas the sum angle was a relationship between angles, and we said you have to know 2 to find the third. For the Pythagorean, which is a relationship between all three sides, you need to know any 2 to find the third. Again, if you're going to state the Pythagorean theorem, this statement you see here where it says c squared equals a squared plus b squared is actually making certain assumptions. It's assuming that it's a right triangle, right? So the assumption is that it's a right triangle, and the second thing is that C is 90 degrees. So you could say in a right triangle ABC, where C is the right angle and lowercase c is of course the hypotenuse, then c squared is a squared plus b squared. Because if you had a triangle like this, well, not even a right triangle, if you have a triangle like this where that's A, B, and C, then clearly this is not a right triangle. So you can't say A squared plus B squared is C squared. That would be incorrect. Likewise, if you have a right triangle where that's C, that's A, the hypotenuse is A, and the other side is, say, B, then again, C squared is not equal to A squared plus B squared. So this is true only when C is the hypotenuse and A and B are the other two sides in a right triangle. So that's important. In any case, that's a more general statement. For any right triangle, and I probably prefer to say side 1, side 2, where this is, or side A, side B, whatever it is. So this is beautifully done. Okay, moving on. Let's maybe do a problem with the Pythagorean theorem, right? Now, this one says, label the lengths ABC. Given A equals 6, B equals 8, solve for C. So again, it's not given here, but this is really a right angle there. C is the right angle in these problems, so we're going to have A, B, and C. So lowercase c is opposite C, lowercase a here, and lowercase b there. Now it said that A is equal to 6. So A is equal to 6. B is equal to 8 units. And you're asked to solve for C. So again, you see, this involves three sides. Side A, side B, and side C. So what involves three sides? Well, it can't be the sum angle theorem. The sum angle theorem involves three angles. So we are looking at three sides. So that's the Pythagorean theorem. So we could say from the Pythagorean theorem, then we know that c squared is a squared plus b squared in this example. So c squared, we know that a is 6, so 6 squared, and b is 8 squared. Now, if you wanted, you could say, well then, 6 squared is 36, 8 squared is 64, that's c squared. Then you add them together, you get 9100, and then that's c squared. So to get c, you have to take the root of 100, which is 10. Okay? Now, if you wanted at this stage here, rather than going there, if c squared is 6 squared plus 8 squared, you could have simply said, well, c is equal to the square root of 6 squared plus 8 squared, and plug the right side directly in your calculator. Now, something I'd implore you to do if you're using your calculator, because I've seen people go around here, you must put brackets there, right? And if you plug that now directly in your calculator, then now you should get that c is equal to 10. All right. Now our next question, where is that happening? C. If I save it, won't happen. Okay, good. So now let's do this other one. Again, triangle ABC, right angle at C. So that's C, that's A, and that's B. So side A, side B, and side C. Now, you're given now that C is 15, 15.0. So that's the hypotenuse. B is 8.00, and you want to solve for A. So again, the hypotenuse squared is the sum of the squares of the two sides. So I need to write A squared plus B squared is C squared. All right. Now we want to find A. So we could say that A squared equals C squared minus B squared. You transpose the B. So it was positive here, it becomes negative there on the right side. So now A is equal to the square root of C squared minus B squared. You have to be careful, right? And then when you plug this in your calculator, you put this in brackets as we said. But let's just plug values in now. Now C is 15.0 squared, and you're subtracting the B, which is 8.00 squared. And if you plug that in your calculator, you're going to get 12.688 again, 577, keep going. However, you have to round based on accuracy and precision. Now, the last thing you did was to take the square root, which really is multiplying, dividing. So we have to round based on accuracy or number of significant digits. Now in this, if you look right here at the numbers that we are using, the 15.0, the 8.00, 15.0, this has 3 significant digits. This also has 3 significant digits. So our final answer has to be 3 significant digits also. So therefore, for 3 significant digits, this has to be 12.7. All right. 1, 2, 3. You look there, look to the right. It's bigger than 5, so you're up the 6 by 1, so it becomes 12.7 units. All right. So here's some practice for you to try, and we're now going to move on to what we call the trig ratios, which was number 3. Remember we talked about 3a and 3b, trig ratios, and also the inverse trig ratios. So that will involve now what happens if I'm given 2 sides and an angle, right? Or an angle and 1 side, which is when you, well, we'll see when we get there. All right. So we're going to be looking at the third thing, which is the trigonometric ratios. On your calculator, you'll see some things looking like SIN or COS or TAN. So beside that, you have to put like an angle here, right? An angle. So we are finding the sine, the cosine, or the tangent of an angle, which is going to give us a value. For sine and cosine, the value has to be between 0 and 1. For tangent, it could be anything. So when you talk about the angle, let's call the angle theta. So the theta here is an angle from our triangle itself. Generally, it doesn't involve the 90 degrees. Some other angle, not the right angle here. It's going to involve one of these angles, either angle A or angle B. So since it's angle A and angle B, we have to know, well then, what angle are we talking about? Is it angle A or is it angle B? So there's a special name given for the angle we're discussing for the particular problem, and that is called the reference angle. So in this case, I'm going to use angle B as my reference angle, and in the second case, I'm going to use angle A as our reference angle. Remember, the reference angle is the angle we're going to be plugging in our calculator or we're solving for. Okay, so the reference angle. Now, we're going to have to learn some jargon, some mathematical jargon relative to the right triangle. So let's go ahead. Well, we know that this is the right triangle here. And in our introduction, I told you how you could find the hypotenuse. Any angle is made up of two sides. So the side that does not contain the angle, so this one over here, this is called the hypotenuse. And we represent that by h. Right? So this is a hypotenuse. Likewise, in this case, that's the hypotenuse too. So the hypotenuse doesn't change. It's always a side opposite the 90 degrees. No, so that's hypotenuse right here, hypotenuse. Now what about the adjacent and the opposite? Now that will vary depending on the reference angle. Well, let's see. So if B, let's talk about case B. If B is our reference angle, then B is made up of this side and that side. So no, not these two sides. The side which does not contain the angle B is what is called the opposite side, or we write it as an O. Then the adjacent is the third one. So this is the adjacent, which we're going to call A. Okay. Let's now look at when the reference angle is A. So again, opposite A would be this over here, opposite, which we're going to call O. So now this one has to be the adjacent, which we're going to call A. So notice that in both triangles, regardless of what the reference angle is, the hypotenuse is going to be the same, but the opposite and adjacent will change. Notice that this horizontal one was the opposite here, but now it's the adjacent on the left side. So the opposite and adjacent will depend on the reference angle itself. Okay. So if we look at these examples here, notice this is a sort of thought experiment. If you were to actually construct a right triangle with a reference angle of 30 degrees there, and you did some measurements, if this side is safe, if the opposite side is 4, the hypotenuse is going to be 8. You could try this if you want. Try to actually construct these triangles. Here's another one, same reference angle, but this side is 12.8, and you'll find that this automatically turns out to be 25.6. It can't be anything else. If you make this 19, then this is going to be 38. Now, an interesting thing happens. If you take the length of the opposite side, which is 4, and divide by the hypotenuse, so opposite over hypotenuse, which is 8, you're going to get 0.5. If you do the same thing for the second triangle, the opposite is going to be 12.8, and the hypotenuse is 25.6. You divide that out, you're going to get 0.5. You do the same for the third, you're going to get 19.0 for the opposite. Hypotenuse is 38.0. You calculate that, you get 0.5. So what it seems is that regardless what the size of the triangle is, then the ratios of these opposite hypotenuse adjacent sides is going to be constant. So this is what we define as our trig ratios, our sine, cosine, and tangent. And we're going to be talking about that just now. So now we will discuss what we call the trigonometric ratios. But before I start, let's sort of play a little game here. If you have, say, 3 marbles, for example, 1, 2, 3. Let's call this marble A, marble B, and marble C. Now, how many groups of 2s can I form? If you don't want to say marbles, just think of 3 people, right? A, B, and C. We're going to label these students A, B, and C. What we want to do is to form groups of 2, just 2. Now, how many groups can I form from those 3 students or 3 marbles of taking just 2 of them? Well, I could have chosen A and B, or I could have chosen A and C, or I could have chosen B and C. There are no other groups, only 3 groups I can form. So in general, whenever we have 3 things, we can form 3 groups. Now, there's not a one-to-one relationship between the number of things and the number of groups. For example, if I have 4 things, it's going to be a lot more than 4 groups, as you could try to figure out, all right? And if I have only 2 things, I could only form 1 group. So not that there are 3 things, therefore I can form 3 groups. That's not the case. Now, so that's 1. From 3 things, I can form 3 groups of 2s, right? Now, the second thing, a ratio involves how many things? Well, 2 things. A ratio is just like x over y. It's a fraction, x over y. That's a ratio. So, if a right triangle or a triangle has 3 sides, sort of like 3 things, how many ratios of those 3 things can I form? Well, there are 3 ratios, right? Because A, O, and H, I can put any 2 of them together in 3 ways. So the 3 ways I can put them together are going to be, I could put O and H to form a ratio. I could put A and H together to form a ratio, and I could also put O and A to form a ratio, right? So I could have, now when I form these ratios, I give them special names. In relation to theta, if I take O over H, let me just erase that. So if I take the first one here, I'm going to label them 1, 2, and 3. If I take O over H and its relation to theta, remember it's always relative to the reference angle. So that's going to, we call that actually sine, S-I-N, of theta. I define sine of theta as the opposite over the hypotenuse. Now I could have called it hypotenuse over opposite, but by definition we just use O over H. All right. For the A, so now we're at A over H. We call that the cosine of theta. And for the third one here, which is O over A, we call that the tangent of theta. So here we have 3 ratios. So let me just put that down here. So we have what we call sine theta, cosine theta, and tan theta. In fact, the proper names are actually the sine, S-I-N-E, but we abbreviate it as S-I-N, not sin, sine. For cosine, it's really C-O-S-I-N-E, but I call it cos. Some people call it cos. I say cos. And for tangent, it's really T-A-N-G-E-N-T, but we shorten it as tan. So sine, as we just said, is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And many of you have probably seen this before. If we just sort of take the S with the O and the H, the C with the A and the H, and the T with the O and the A, you end up with SOH coming from here, and then coming from here you have CAH, and coming from here you have TOA. And you've probably seen this before, SOHCAHTOA. So that's a sort of memory aid to remember what sine, cosine, and tangent are. All right? Now, let us look at this example here. It says, given an angle, you could use your calculator to find the ratios. Well, the ratios, really, all the ratios for sine, cosine, and tangent. All right? Now, well, to find, notice that if this is our reference angle here, then this is going to be the opposite. The 8 is going to be the hypotenuse, but the adjacent is missing. Well, we could find the adjacent easily, right? If you remember that to find this side, it's one of the shorter sides, not the hypotenuse. So we could say that a squared is going to be equal to the hypotenuse, which is 8.00 squared minus 4.00 squared. So therefore, a is the square root of 8.00 squared minus 4.00 squared. And that works out to be approximately 6.93. You could verify that. So A is 6.93. Now we're going to do two things. Here it says find the ratio from the triangle, and then here we're going to use our calculator. So from the triangle, sine of 30 is opposite over hypotenuse. So it's going to be the 4.00 over the 8.00. Now if you plug that in your calculator, you're going to get 0.5. Cosine of 30. Now cosine is adjacent over hypotenuse. So it's a 6.93 over 8.00. And if you plug that in your calculator, you're going to get 0.866. Let's do that one again. I'm going to erase this and this, right? Let's go again. Cosine, if you remember, going from here, cosine is adjacent over hypotenuse. The adjacent is 6.93. The hypotenuse is 8. So cosine is 6.93 over 8. Now for the tangent, what's the definition of tangent? Well, tangent is opposite over adjacent. Well, we have labeled this already. So the opposite is 4. So it's 4.00. And then the adjacent is the 6.93. And if you put that in your calculator, you're going to get 0.577. Okay, good. Now, if you do the same thing now for this column, for this row here, if you enter sine 30 degrees, now calculators are different. In some calculators, and I hope the one we're using for this course, I believe, if you enter sine first, then 30 degrees next, then you press enter, and what do you get? Do that for me and tell me what you got. Well, no surprise, you got 0.5. Now you have to be careful. Make sure make sure that your calculator is in what you call degree mode. If you look right here, if you look right here, you see that little sign there. That after the 30 degrees, that's your degree sign. So make sure that your calculator is in degree mode. All right. So now you go sine, cosine 30. Oh, I was saying, For most calculators, you'll put sine then 30, but for some, you have to put the angle first. So you have to put 30 degrees or just 30, then you press sine and you'll get your 0.5. But I wouldn't recommend that calculator. I'd recommend the one that you put the sine first, then the 30. Now for the second one, cosine of 30, and you should get the same thing, 0.866. And then if you in your calculator you put tan of 30, then you should also get 0.577. Right? So now we're going to be looking at 3 examples. So let us look at 3 examples involving using the trigonometric ratios. So if you go back to the introduction, we're in 3a. We're going to be finding a side given an angle, and a side we're going to find another side. And the final thing we'll be looking at is if you're given 2 sides, how do you find an angle? And that will involve what we call the inverse trig ratios, which we talked about at the beginning. But now we're looking at just finding a side given one side and an angle. So in this first case, notice that we're given a side and we're given a reference angle, and we want to find another side. So can we use the sum angle theorem? No. Remember that our toolbox so far involves the sum angle theorem, which says that the sum of all three angles is 180 degrees, but in a right triangle, since one of the angles is already 90, then the other 2 angles, they add up to 90 degrees. So we can't use that here because we want to find a side. Right? So you can't use something involving 3 angles. Okay, the second thing was the Pythagorean. Now the Pythagorean involved 3 sides. We need to know any 2 to find the third. Is that the case here? Do we know 2 sides? No, we don't. We only know 1 side, so the Pythagorean theorem is out. So we are now left with the SOHCAHTOA, sine equals opposite over whatever it is, and you keep going on. SOHCAHTOA. All right. So we know we have to use SOHCAHTOA. So I'm going to write SOHCAHTOA. At this point, we are not sure which one we're going to be using as yet. As you get more proficient, then you don't have to be doing what I'm doing here, writing these things down. You just look at it and you'll just know what to do if you do enough practice. So let's see now which one do we use? Well, the first thing I would do is to label opposite, adjacent, hypotenuse. So this here, 50 degrees, is our reference angle, right? Now the hypotenuse is always the same. So the 21 is our hypotenuse. It's the side opposite the 90 degrees. Now opposite the reference angle is A, so that's now called the opposite. Okay, so we don't care about this side here. We don't care because we're not asked to find it, so we don't care at this point in time. Okay, so we are looking for a relationship involving the opposite and the hypotenuse. Opposite and hypotenuse. So what is that? Well, it's this one here. So it says sine is opposite over hypotenuse. So we have to now use the sine ratio, the sine of the 50. So we set up now that the sine of 50 degrees, okay, this little bar means that this 50 degrees is correct to 2 significant digits. Without the bar over the 0, it would be 1 significant digit. Now sine is equal to opposite, which is the A that we don't know, the A, over the hypotenuse, which we know to be 21 centimeters. Good. So here is where your formula manipulation comes in. All right. So now how do I find A? Well, if I just multiply both sides by 21, then the 21 goes, and I'm left with A is 21 centimeters times sine of 50 degrees. And now it's a matter of plugging that in your calculator, and our answer has to be rounded to 2 significant digits, and you know why. So it's going to be about 16 centimeters. And that's all there is to it. All right? So let's recap. You're given a problem. You first of all said, well, what in my toolbox do I need to use? Is it the sum angle theorem, the Pythagorean theorem, or SOHCAHTOA, the trig ratios? Well, we know why we eliminated the first two, the sum angle and the Pythagorean. So now we are left with the trigonometric ratio, SOHCAHTOA. So I wrote down SOHCAHTOA. Then we labeled what's adjacent, what's hypotenuse, what's opposite, right? To determine which of these three we're using. All right, and then we use a formula, manipulate, and get a solution. Let's look at a second example here. Again, we see that we have the hypotenuse. Well, you will figure that out. And so we have two sides and an angle. Two sides meaning one of the sides we need to find, one is given, and we're given an angle. So we have to use again the trig ratios. So SOHCAHTOA. Now we don't know which one is yet. Well, let's figure it out. We are given this reference angle. Relative to this side here is the opposite. The side B, which we want to find, is the adjacent, and the one you know is the hypotenuse. Again, we don't care about the opposite at all. All right, so I'm going to put an X here. We don't care about that. So we're looking for, we know H, and we want to find A. So what ratio involves A and H? Well, we see it's the cosine. So we just say now that the cosine of our reference angle, 52 degrees, is adjacent, which is the B, and over the hypotenuse, which is 31.4 inches. And I'm going to leave this for you now to figure out. I won't. This is just formula manipulation. So from that we get that B is 31.4 inches times cosine of 52 degrees. And if you plug that in your calculator, you're going to get B is 19 inches. Now notice that I've rounded my final answer correct to 2 significant digits. Why is that? Well, this number here, this length has 3, but the angle has only 2, so we use a minimum, so it has to be 2 significant digits. That's going back to what we did in the course. All right, let's look at our third example, which says find the length of C. So now you're getting into the whole thing. Again, you're given an angle and a side. We want to find a third side. So we're going to be using again the SOHCAHTOA. But we have to know, well then, which of these three will we be using? Well, let's label our angle. So that's our reference angle. The C is obvious, so the hypotenuse is opposite the 90 degrees. The 245 is our adjacent. We don't care about any other angles. So now we're looking for a ratio involving adjacent and hypotenuse. So again, it's that one, the cosine. So we set up our equation and say that the cosine of 18 degrees is the adjacent, which is 245 millimeters over the hypotenuse, which is C. All right, Now, this is a little bit different from the first two because now we have the variable in the denominator. I'm just going to be kind and remind you how this is done. So we want to find the c, so we multiply both sides by c. So the c goes, we're now left with c times cosine 18 degrees is 245 millimeters, but we want only c by itself. So we now divide both sides by the cosine of 18 degrees. So now that goes, and you're now left with c is 245 millimeters divided by the cosine of 18 degrees. And you simply plug that in your calculator and you get 260 millimeters rounded. Now, why did we round? Again, look at what went into the formula. This number right here has 3 significant digits, but the angle has 2. 2 is less than 3, so we round this to 2 significant digits. Right, so let's do a quick recap before we move on to the solving for angles. So we're solving a right triangle. One of the tools is what we call the sum angle theorem. So if it's a relationship between all three angles of a triangle. If you know any two, you could find the third. The second tool was the Pythagorean theorem, which is a relationship between all three sides. Again, if you know any two, you could find the third. The one we just looked at was the trigonometric ratios, which is the SOHCAHTOA, which involves an angle and two sides. But the previous three examples we did, we were given an angle and a side, and we had to find another side. Okay, so we are still on the SOHCAHTOA, which involves two sides and an angle, but now you're going to be given two sides, very important, which is different. We are given two sides and we want to find an angle. So that's a difference. Whereas in the previous three examples, you're finding a side, but in these examples now, you're going to be finding an angle. So just to make things a little bit easier for you, let's just go through what is here. All right, we're going to be just doing a little experiment here. Now, in your calculator, could you sort of do this for me? Find sine of 45.3 and the cosine of 15.6 and the tangent of 83.8. So at this point, you could probably pause your video and just do this for me, and then I'll write them down. All right. Okay, so there you are. I found the sine of 45.3, the cosine of 15.6, and the tangent of 83.9. I wrote my answer here, my ratio. Remember, these are ratios on the right side to 3 significant digits. All right, now supposing that you knew that the sine of some angle was equal to 0.710, and also that the cosine of some angle, let me call that theta 1, theta 2, was equal to 0.690, and also that the tangent of some unknown angle theta 3 was 9.21, and we wanted to find what theta 1 is equal to what's theta 2 and what's theta 3. So we want to find what they are. So what do we do? Well, obviously there's a way, otherwise I wouldn't have led you this far just to disappoint you. Now, if you look on your calculator, just above sine, you see something looking like sin -1. If you look just above cosine, you'll see cos -1. So if you do like second function or inverse cosine, you get access to the one above. And above the tangent, you should see something looking like tan -1, right? So all you have to do is to put the values here. The 0.710 there, which is this value, and also 0.690, which is this here. And for tangent, you put 9.21, right? So I'm going to tell you how this reads. The sine -1, and listen carefully, the sine -1 means you could read it as the angle whose sine is 0.710. The angle whose sine is 0.710. So remember, when you see the -1, you're finding an angle. For theta 2, it means that theta 2 is the angle whose cosine is 0.690. And for the last one, you say theta 3 is the angle whose cosine is 9.21. Now, if you plug that in your calculator, then for this one, you're going to get that. You're going to get the 45.3 degrees roughly. If you do the inverse cosine here, you should get 15.6, and for the tangent, the theta 3, you should get your 83.8, right? So let's do a quick recap. So if you know that sine theta is equal to some value a, then you could say that theta is the sine -1 of a, and the same thing goes for cosine and tangent, and it's called the inverse sine, inverse cosine, inverse tangent, or the inverse trig ratio. So now let's just do an example. All right. So in this example now, as we said, you're given two sides, and it says find angle A. So we want to find angle A. That's our reference angle. So again, we have to label, or we're going to have to be using, again, same thing, SOHCAHTOA. All right, now let's see. Relative to this angle, the 6.84 is our hypotenuse, and the 4.27 is our adjacent, right? Adjacent. This side over here would be our opposite, but we don't care at this point in time. We're given two sides, which are the hypotenuse and the adjacent. So what involves adjacent and hypotenuse is a cosine. So that we want to find angle A. So we set it up just as we did before. So we said that the cosine of angle A is our adjacent, which is 4.27 over hypotenuse, which is 6.84. Now you don't need to actually work the right side out. You could just now say that therefore A is the angle whose cosine is, which is cos -1, 4.27 over 6.84. Now I would suggest you put the brackets there, otherwise you're going to run into no end of problems. And if you plug that in, you'll get that A is 51.4 degrees. Now notice here that we use 3 significant digits, and you'll see why. All right. Okay, so yeah. Now there is something here about the textbook rounding rule which you should read, right? And then we have some examples here. Which we will do just now. Alright, so this says that sine A is 0.605. So we could say that therefore A is the angle whose sine is 0.605, and that works out to be 37.2 degrees. With our rounding, cosine B is 0.437, therefore B is the angle whose cosine is 0.437, and that works out to be 64.1 degrees. And for this last one now, we want to find what A is. So A is our reference angle. This 11.3 is our opposite. The 16.5 is our adjacent. So SOHCAHTOA. So we're looking for a ratio involving opposite and adjacent. So that's tangent. So we could say that the tangent of A is 11.3 over 16.5. Therefore, A is the angle whose tangent is 11.3 over 16.5. You plug that directly in your calculator and you get 34.4 degrees. So that's all there is now for the inverse trig ratios. So now we're going to look at some further examples in solving a triangle. We're at the point now where we're going to be putting everything together and determining all the unknown sides and all the unknown angles in a right triangle. So here's a sort of list of things that you should do in solving your right triangles. At this point in time, you already know exactly what to do, but we'll just go over it for completeness. So to solve a triangle, I would say to solve a right triangle, there are other non-right triangles, which there are other techniques that you could use to solve them. You've probably heard of the sine rule and the cosine rule, but that is beyond us at this point in time. So we're going to be solving just right triangles. So the first one here says sketch a triangle and label with information provided if the diagram is not provided. Well, we have done that. We have been doing that. If only have sides, use Pythagorean theorem. Well, we talked about that. You use the sum angle theorem when you have, which involves all angles. The Pythagorean is if you have all sides, and for anything else you use the trigonometric ratios. Third one, for reference angle, determine the side information given. Well, we've done that too, right? We've labeled the opposite, hypotenuse, and adjacent. Determine with trig ratios. Notice that for every single question we've been doing, I actually wrote down SOHCAHTOA. And then we circle whichever one we need to use. But that can only be done once you label your opposite, adjacent, and hypotenuse. And the last thing is to sub the known information in the appropriate formula and solve. Now, notice it said sub here first, then solve. So it's given sub and then solve. Now, this could be done the other way around. You could solve for the unknown first, for the variable, and then you substitute in the formula depending. Okay, anyway, let's do an example here. Okay, so solve for the missing component. So in this case now you're solving the whole triangle. You're finding all unknowns. So let me just draw the triangle over here. Again, it says BC, so we think it's a triangle ABC. with right angle at uppercase C. So that's C, that's A, that's B. So down here is our lowercase a. Here is our lowercase b side B, and here is our side C. Now what are we given? This is 90 degrees at the C. It says that B is 73.6. So I label that 73.6, and that's centimeters. We know that angle B, it's 19.0 degrees. So we know that, right? So what are we solving for? Well, we're solving for the unknown sides and unknown angles. Well, let me just sort of do this in green, what we are trying to solve. So we want to solve for angle A, which we don't know. We want to solve for side C and also side A, right? This is all already given. So how do we do that? Well, let's start from the first thing, the sum angle theorem. Could we find the unknown angle? Well, yes, because this triangle has three angles. The 90 degree is already given, right? And there's another angle here which is 19 degrees. So the question now becomes, can I find angle A? Well, yes, because we give a sort of special case that in a right triangle, the other two sides, excluding the 90 degrees, the right angle, these two angles here must add up to 90 degrees. So we know that A plus B, it's 90 degrees, and we want to solve for A. So we could say that A then is 90 degrees minus B, which is the same as 90 degrees minus, we know that B, it's 19 degrees. So A then is 19 minus 90, which is 71.0 degrees. So that's our angle A. All right. Now notice what I did here. I solved for I isolated for A first, then I plugged the value for B. Now if you wanted, you could have also said, I'm going to say R, we could have said that angle A plus the B, we know it's 19 degrees, 19.0 degrees equals 90. So therefore A is 90 degrees minus 19.0 degrees, and we still get A is 71.0 degrees. So this is now plugging the value in first, then solving as I said previously. But in the first case, I isolated for A first, then plug the value in. So it makes no difference. All right. So now we have found angle. We have found angle A. So that's done. So what is left to be found now? We have to find side A and side C. So you have to determine, what do I want to find first? Doesn't make any difference. So let's say that we want to find, first of all, side A. We want to find side A. All right. So let's see what we're given now. Well, we know, we have to now label our thing opposite, adjacent, hypotenuse. So the C is our hypotenuse relative to the 90 degrees. Well, it's always going to be the same for the hypotenuse. But for the 19 degrees, A is actually the adjacent, and the B is our opposite. So we want to find what side A is. Now side A is the adjacent, and we're given B, which is the opposite, right? So opposite over adjacent, yes. So let's go again. We want to find A. We could have said we want to find C first, but just arbitrarily, let's say we want to find D. We want to find side A. Side A is the adjacent. We're given B, which is the opposite. So we say, well then, what ratio involves that? So let us put this here. So SOHCAHTOA, right? So we're saying, what ratio involves adjacent and opposite? Well, it's a tangent. So now we could say that the tangent of 19.0 degrees is opposite, which is our 73.6, and you're dividing by the A, right? And how do you solve for A? Well, I'm going to leave that for you as an exercise. So from which, if you do your formula manipulation, A will be equal to 73.6 centimeters divided by the tangent of 19.0 degrees. And if you plug that in your calculator, you're going to get A is 214 centimeters. So now we have A. All right. So now the only thing left for us to find, we're going to go up here, the only thing left for us to find now is C, right? Now you have a few choices for C. Because we already have B, which was given, and we have found A, so now we know two sides, we could find C using the Pythagorean theorem. However, that may not be the recommended choice. Why? Because you're now calculating C, assuming that the value of A, the value A that you found from here, that this A is correct. Now we believe it's correct. But under exam conditions, and we're humans, we're not perfect, you could have made a mistake. So I would suggest you stay away from that and try to use the things you were given to find C. All right. So let's just I'm going to sort of redraw this triangle. It's getting a little bit messy there. And we want to find C. We know that this is 73.6, and we know that this is 19 degrees, and we want to find C. Well, let's label again. This is the hypotenuse. Well, the side, this 73.6 is the opposite. So using our SOHCAHTOA, we're looking for a ratio involving opposite and hypotenuse. So that's the sine. Not as messy here. So we could say that the sine of 19 degrees is opposite, which is 73.6 centimeters over the hypotenuse, which is our C value. And again, manipulating, we're going to get C then is going to be 73.6 centimeters, and you divide by the sine of 19 degrees, and that C will work out to be 226 centimeters. So now we have everything. We have our unknown angle A, we have our side A and our side C. That's all there is to it. The last thing we'll do now is to look at two practical examples of solving right triangles. The difference between this and what we've done is that the good news is that you don't have to solve for all unknown angles and all unknown sides. In this case, you're just going to be solving for one thing, either an angle or a side, generally. So let us jump into this. Now, there's nothing new here. In solving these word problems, it's always good to do two readings. You read once for just a general understanding, and then you read a second time and you try to draw your diagram. From the diagram, you could solve your triangle. We're trying to get a right triangle and solving for a side or an angle. Now, you don't have to be an artist. You should just sort of try to end up with like a triangle. Let's just do the first one here. The CN Tower is 553 meters high. If the angle between the ground and the line joining the end of the shadow to the top of the tower is 37.0 degrees, how long is the shadow? So let's do this one. So what you have is the CN Tower and the ground. You're assuming that the CN Tower is 90 degrees. It's not lean like that leaning tower of fame. So it is, the CN Tower is 553. So it's 553 meters high. Okay. It says the angle between the ground and the line joining, so between the ground and the line joining the end of the shadow, the top of the tower. So let's assume that the shadow of the CN Tower, so the sun is somewhere, there, and it's casting a shadow down. So the shadow now ends right here. So that's the end of the shadow. Okay, so the angle between the ground, which is here, and the line joining the end of the shadow, which is here, to the top of the tower. So it's this, the angle that is made up of those two sides. So that's the angle right there. That's our reference angle. And it says that angle is 37.0 degrees. Now it says, well, how long is the shadow? So let's call that length L. That's the length. The shadow is always on the ground. So that's our diagram here. So again, let's sort of label our opposite, adjacent, hypotenuse. That our reference angle is 37. So the 553 is our opposite, and we want to find L, which is our adjacent, right? So let's do this again. So So we're looking for a ratio involving opposite and adjacent. So that's tangent. So we now could say that the tangent of our reference angle, which is 37.0 degrees, is opposite, which is 553 meters over the L. And then we manipulate and solve for L. I'm not going to go through this. We've done this before. So if you don't know how to do this, you have to go back and look at solving linear equations. All right. I did a little of this at the beginning of this class too, but you have to learn to walk. All right. So now L will be just equal to the 553 meters over the tangent of 37.0 degrees, and if you plug that in your calculator, you're going to get 734 meters. See, that didn't take any time whatsoever, not too long. So that's it. Let's look at our second example here, second and final example. It says, now notice in the first case you had to get your diagram. In this case, a diagram is given, so that makes it easy. The given diagram shows the impedance triangle for an RL circuit, series circuit. You're given that R is 8.2 kilo ohms and XL is 2.4 kilo ohms. Now kilo means times 1,000, but we could express our answers in kilo also. So it says example A says find the impedance Z. So impedance Z is the hypotenuse. So notice that you're given R and you're given XL. So it's sort of like three sides of a triangle. So and we want to find, so you're given 2, you want to find the third. So that's not the sum angle theorem, it has to be the Pythagorean. There are no angles involved in part A. So to find Z, which is a hypotenuse, we just say for A, we just say that Z squared is R squared plus XL squared. Therefore, Z is just equal to the square root of R squared plus XL squared, which is the square root. We know that R is 8.2 kilo ohms, so 8.2 squared, remember that it's kilo ohms, plus our XL, which is 2.4 squared. And if you plug that in your calculator, you should get 8.5, but remember it's kilo ohms. Okay, so that's our Z value, and that's all there is to it. Here's the second part. It says find the phase angle I. Aha, so now that's our reference angle. Now I know what Z is, but again, this is what I said to you previously. I would not use Z in my calculation for I. Why? I might have made a mistake in calculating Z, which would make my I value off. So I'm just going to be using the R and the XL. So now we know two sides and we want to find an angle. So we have to use that inverse trig ratio. Right? Let me just clean this up a little bit and then we will see how to do it. So we know that R is 8.2 kilo ohms, the XL is 2.4 kilo ohms, and we want to find that, the angle I. So relative, we're going to have to do our labeling, our opposite, hypotenuse, adjacent. So we know that the Z is always, this is the hypotenuse, which is the opposite of the 90 degrees. Relative to I, this XL is the opposite and the R is the adjacent. But we won't be using the hypotenuse because in case we made a mistake. So we want to find a ratio involving adjacent and opposite, right? So let's see that. So we have SOH CAHTOA. So what ratio involves opposite and adjacent? Well, it's the tangent. So we now could say that the tangent of the I, which is what we want to find the angle, is opposite, which is our 2.4 over the 8.2. Now at this point, you don't have to say kilo ohms, and I show you why. If I had put kilo ohms here or multiply 2.4 by 1,000 and put kilo ohms, then because I have the same thing top and bottom, they cancel, and I'm just left with 2.4 over 8.2. Right, so now we can say therefore the angle I is just it's the angle whose tangent is, so tan negative 1 of 2.4 over 8.2. And if you do that, you now get that the angle is just 16 degrees. All right, so that's a lesson. That's a wrap.